Hello to this recording. We are celebrating the Nobel Prize in Physics 2025. Yay!
Well,
Because it went to
fantastic.
quantum physics. And Hans, please tell us something about this Nobel Prize in Physics.
It's it's just incredible. After many years, well due. Uh, well, it's about 40 years almost. I think you could take that away because I think it's too small to see.
Mhm. Okay.
It's also dragging my picture down a bit.
Mm.
Uh, See if my picture will return in a second until I return.
So Hans, tell about the prize in Nobel Prize in
Yes,
Physics 2025.
yes,
Why is it important? Why is it
yes.
important?
It is. Could you take my picture back again so I can see myself? Give me a second here.
So Hans, tell us about the Nobel Prize in Physics. The world is
Yes.
waiting on you. So
Well,
why
I'm
is it
waiting until
important?
my. Where did my video go? Disappeared.
You want to see the? You said
Yes,
you
I want
didn't
to
want
see
to.
my video. Yes, yes. Thank you.
Okay.
Much better. Well, the most marvelous thing is that finally there's a Nobel Prize given to uh, the ones who said macroscopic tunneling is actually possible. So I think the more normal view of everything is that quantum effects disappear at small levels. But quantum effects linger on to greater levels. And here they are taking out an electric current. And we are, talk, we are talking about an object that is 10 up to 6, 10 up to 6, that's a million wise object. So it's much larger. So that makes a whole difference. And tunneling is the concept of something being at one point and turning up somewhere else.
Mm-hmm. Mm-hmm. But the word tunneling is a little bit misleading, I think, for the general
It's
public.
not misleading. It's the term that it is. I don't think there could be any more appropriate word, but another way to explain the whole thing is being in one place and then being in some other place all of a sudden.
I have a proposal of another word, not tunneling, but bilocation. Bilocation. So it's the
Possibly, possibly.
miraculous ability where an object is in two distinct places at the
Mm,
same time. Do you think it
mm.
describes tunneling? Is it
Yes,
what
of
is?
course, it does. It does.
Hmm.
It does. It fits the
So
picture.
tunneling, because in the normal language, it means something that you go like through a tunnel. If you are a driver, you go through a tunnel, and then after a while, you are on the side.
Yes, it
It's
it
nothing
it.
miraculous in that.
It's well, it's yeah, well. Channeling is the acclaimed term since a very long time ago, but it means simply that something is at one point, at one, let's call it point A, and then a second later or a moment later, it's in position B, where it's completely different position. And this is a state of the fact not only with small objects like an electron. We usually think about an electron tunneling, which they can do pretty frequently when it comes to tunneling in a half liter in the crystal chips that you find in a mobile memory slots and so on.
But I don't completely agree with your definition because perlocution is that one object is at the two spots at the same time. One object
It,
is at the two. So, like me, I would be like at the same time in Sweden and in Finland, let's say, at the same
yes,
time.
yes, yes, yes,
So you agree with that definition. So
yeah. You have to
one
fit
person
same
like me,
time.
I am in two different
Yeah, yeah,
countries at the same time.
yeah.
So
But you can't use the expression same time in quantum mechanics. It doesn't exist.
so what would it say? Because time doesn't exist
No,
as And if you compare with classical physics, would they allow for bilocation?
It's a huge difference. In classical physics, you have time and you have location, two things that does not exist in quantum mechanics. But the most important thing is the discovery or the acknowledgement, you could say, by the Nobel Committee that bigger objects than just a mere one electron. Can you see my?
Yes, I see your finger. Yes, I see.
You can
So
see.
what? No, lift it a little bit, like at your show at your level of your face. Yes, now I see it. Yes.
Okay.
So okay.
Before it was only one object, and I think that's the acclaimed idea. Only one object, or one atom, or one electron, if you like. Now that figure goes up to 10 up to the potential of 6. That's a million. So even though it's a very small object, it makes the whole difference. Because usually people say that quantum mechanical parameters only hold in very small areas. And that it disappears once you go up to the macroscopic level. This is not true. No longer.
I see.
It continues into the macroscopic level. And they used to call that coherence, decoherence. Decoherence makes quantum mechanical factors disappear at a higher level. And I've taken that to be a sort of argument that on higher levels, classical physics resides. Could you possibly take away the screen sharing thing so I can see myself instead?
So, do you want to have this screen sharing on? No.
No. It's just a bit disturbing. Yes.
Okay.
If you can, please. Yeah, it's much better. Thank you. So the higher level is much. I think 99% of the population means at a higher level, the classical physics resides. So it's still alive, so to speak. But very far from the point. It goes to higher objects. That means potentially that the Empire State Building can do tunneling. So it could be situated nice and cozily in Manhattan, and then all of a sudden appear on Mars.
So
this is what could happen.
So in classical physics, I would be only Sweden, but in quantum physics, I would be in multiple countries at the same time.
You can be all over the place. Location doesn't mean anything. It's Heisenberg's indeterminacy theorem.
Hallelujah. I can travel all the world now. Be in
teleportation
I want to be in Hawaii. I think
teleportation is the reality. It's the reality.
So we could even call this not bilocation, which is only 2 places, but trilocation, 3 places, 4, and so forth, so forth. You get the point. So multiple locations, you could call it. They prove multiple locations at the same time.
Yeah, and it doesn't go against quantum mechanics. It's actually a factor within quantum mechanics. All places at the same time. Yeah.
So it's a revolution in science.
It's very, very important, and it's long overdue, the prize. It's acknowledgement that teleportation or tunneling or whatever you want to call it, bilocation, it's also on the higher level. Because we already know it's possible in the smaller level, but now it will be reinforced, the fact that it is possible on a much larger macroscopic level. Isn't that fantastic? I think
absolutely. Let me show you. Let me share something fun with you. So let me see.
Let's hear.
So the 3 people who got the who shared the prize, they called John Clark, Michel Devoré, and John Martinis. So let me do a pun with martinis here.
Okay.
And now we could celebrate this uh, this victory, this prize with a martini.
Why not? It's a good
Okay,
social drink.
I don't promote alcohol here, so it's better alcohol martini without alcohol.
I think you can make an alcohol-free martini, maybe.
So, and here behind me, I will show the in beautiful location in Gothenburg. I will celebrate
Yeah.
also with Venus, who is here is behind the Venus is also Aphrodite is also uh, is also she's now at the same time celebrating with us. She's at the same time in Greece and in Sweden.
Yeah. It's not nowhere. Yeah, Aphrodite is from Greece. That's true. Yeah. Okay. Let's finish
So
there. Thank you very much.
thank you, wonderful. Let's
Bye
celebrate
bye.
with
Bye bye.
martinis.
Yes. Bye bye.
Goodbye, goodbye.